So today I'm going to talk about my final project. The final project is about the congestion pricing plan in New York City. So it's going to be the first, New York City going to be the first city in the United States which is going to have this congestion pricing plan. So the plan basically is saying that if you have to drive your car or have to if you have to drive your car or trucks or taxis into the city and start from 59th Street, you're gonna start to pay for the fee, the entering fee. So what they suggest the number for the fee, which is gonna be like $11 for the regular vehicles, like $25 for the truck. So I mean, after this news comes out, and a lot of people have different opinions about it, it become pretty controversial. So for me personally, I don't have to commute to New York City every single time. So it seems like not a big deal to me. But for people who have to commute to New York City every single time, like every day from Monday to Friday, and especially if they have to drive their car, then that become a really huge financial burden for them. So a lot of people likes it. A lot of people like it, but a lot of people still don't like it. So from my project, I try to be more objective. Try not to show like I hate it or I like it. I just want to see if the data can tell us any stories behind it. So in my data, I couldn't find anything like 2019, which is a pretty recent one. But I can find the traffic count, volume count from the NYC. I think I have the website right here. Yeah, from the NYC Open Data. I found the two data sets actually. The first data set is just the basic traffic volume count from 2014 and 2018. And the second one still is from 2014 and 2018, but we have they tell us which type of vehicles driving at that time. So like maybe the taxi, maybe just auto, or maybe truck. What kind of truck is this? So I feel like these two right here are pretty useful for my data visualization here. So I'm using these two data sets from NYC Open Data. And also another one I find is from EPA.org. This is another data set I have. The reason why I'm looking for the EPA.org. So when we talk about this congestion pricing plan, mostly we talk about the price, money-wise or finance-wise. So we were saying, oh, they probably is too much money, or maybe it's good for for the public. They can fix a lot of subway system, everything. So we always considering stuff from the financial reason. So that's why I took this data set from EPA.org, which is in environmental data. So because like if less car gonna drive in Manhattan, so I think it will change the environment, like air pollutions, noise pollutions, gonna change a lot on this as well. So that's why I collect another data from the environmental open data set. So in this case right here, I just collect 2015, 16, 17, and 18, pretty recent. And then I find that the data set is very useful because it's very organized and it has all of the states, as you can see here. This one right here, because I did a head of the data frame, so it only showed the first few. But it shows us every single state and every single county from that same year. And also they tell us is how many days with AQI. AQI represented for air quality index. Also they tell us about the good days, how many good days we have, how many unhealthy days we have, and also they tell us like how many like the days for the where is it? Okay, PM 2.5, how many days for ozone action days. So I think it's a pretty good data set I'm gonna use. So after I clean up all of my data set, I just need a New York. So for 2015 to 2018. So first of all, before I do that, I actually calculate the mean, the average for the categories I'm gonna looking at. So basically, I'm looking at the three categories. One is the good days, one is the days of ozone, like ozone action days, and days of PM 2.5. So the reason why I'm looking at the good days, now of course, good days is just in general, is measure how many good air quality days we have. But like for ozone action days, I think it's pretty important because ozone basically is the big reason for the global warming. So we just want to see like how this ozone days work. And also for the PM 2.5. Now PM 2.5 basically is come from the vehicles. So when the PM 2.5 is very high, then it's not good for human bodies. So that's the three categories I'm gonna looking at. So after I organize all of my data here, and I come up with these three charts. The first chart right here, again, for all three charts here are the lollipop chart. I like it because it keeps very simple. So at the beginning, so I'm going to talk about those from two points of view. Now, for the first point of view is just by looking at the graph. Now, technically, let's just talk about technology here. Technically, I think it is a very simple and neat graph. Before I did histograms, and the histograms filled with colors, even with different colors. The problem for that is it's actually distract my attention about the graph itself. So, but for the lollipop right here, the lollipop graph is it shows the points, and also this right line right here is considered as the average good days in the entire United States. So I think this entire semester when we talk about this discussion right here is we always talk about like less is more, keep it simple. That's the thing that I always keep in my mind, like keep it simple. So after I get rid of the colors of the histograms, change from the rectangle become just single line, it's actually become really, really neat, and it's really easy to see that how the thing's going. And my second point of view, just by looking at the graph itself, is we can tell that for the good days, now just look at the data. So for the good days, 2017, that's the only time we are slightly above average, and all the others, actually 2018 as well. Like 2015, 2016, both of them are below average. I mean, average is fine, but like as New York is the biggest probably city or the most fascinating city in the United States or maybe in the world. So I think if we can keep our environment better, that will represent for a really good model for other cities as well. So I think like below average maybe is not really looking too good for our environment. And also if you're looking at the number of ozone days. Now for number of ozone days, when the ozone action days like showed up in any like environment website, that means people should try to stay inside instead of going outside, because outside probably is there are environmental reasons, like maybe some of them will hurt your health, everything. So now as we can see right here, so from 2015 to 2018, only 2018 is slightly higher than the average, but for 15 to 17, all of them are lower than the average right here. So I think it is a good sign because the higher the days, like the higher amount of days, it means you need to be more careful with the environment. I think the biggest reason right here is because ozone it get affected by the temperature as well. So New York is in East Coast and it's pretty cold most of the time. I think that played an important role in this data set right here. So it is lower because it's not because we don't have cars or we don't have a lot of cars. It's just because I think the weather here is really, really cold. Like in the winter time, we pretty much have like half a year is like in the cold winter time. So I think that is the biggest reason why we are lower than the average of the national wise. And now if you're looking at the PM 2.5, now the PM 2.5, we can see right away right there is we are way above the average. And now the PM 2.5 is mainly come from the vehicles. And now from this diagram, we can easily to see that the amount of cars, the traffic jam in the New York City definitely gonna be a problem. It's gonna hurt a lot of people's health. It is a big issue right there. So now after this environmental concerns, and I move on to the traffic volume count. Now the traffic volume count right here, the data set I find is from 2014 to 2018. So the reason why I didn't use 2014 and 18 is because 2014 is they only collected data from probably April, I think it's April to November. And 2018, they only collect the data from like January to April. So in this case right here, I don't want to make my graph biased too much. So before I was thinking about doing the entire year, but since they didn't really collect the data for the entire year, so that's why right here, I'm just gonna get rid of 14 and 18 and just do 15, 16, and 17. And then also, I think it will be easier to just using 1 month data set to represent. So that's why I find well, it's not the only month, but it's the month that all three of years in common, which is October. So I find October. And the interesting about this data set is they actually count, as you can see right here, is every single hour. So from 0 a.m. to 1 a.m., 1 a.m. to 2 a.m., and all the way up to the 11 p.m. to 0 a.m. actually. So it is very interesting because they have all 24 hours number. But it's actually make the graph is a little bit more difficult to do because there are like 24 intervals and gonna fit the graph. So in this case, I Googled online actually. I Googled online and I find that it's called a clock graph. This is what I have for the clock graph. Basically, is make a circle, and then circle is kind of like a clock. So each hours right here, and then also each, as you can see, the color that represent for the frequency or the number of vehicles we have at that moment. So I think this is a pretty interesting, and as you can see the trend right here is between like between like 11 p.m. to like 4 a.m. is definitely is low right here. And after 5 a.m. start to pick up and all the way to like 7 p.m. 19 to 7 p.m. So it makes sense because in the morning is a rush hour. People rush into the city for work, and then at the end of the day, like after work, they're gonna go back to their home. So like right here is really, really high frequency there. Now, as you can see, 2015 looks like this, and 2016 also look like this. So slightly different. 2016 probably have a little bit higher between the 12 a.m. to 12 a.m. to 12 a.m. Yeah, 12 a.m. to 1 a.m. right here. But the trending still is the same. So it start from like a 5 a.m. to pick up and all the way to 7 p.m. And same thing for 2017. It will be the same idea. So after I got this 3 clock graph right here, I mean, I'm not too satisfied for what I get. I can see the trend right here, but I still cannot tell like what's the difference. So I want to do a comparison between these 3 years. So in this case right here, I did a histogram to compare these 3 years. But the problem right here for this question is, as you can see, it's a very overwhelming graph. There are like 3 bars for like 1 period of time, and then there are 24 of them. So total is 72 of them. 72 bars. That's a lot to analyze. So in this case, I googled again, and I find a very interesting package. It's called the GG Animate actually. So I changed that into the animation. So the reason why I changed to animation is, again, I follow the same rule here. It's called less is more. At the beginning, when I show all of the graph at one time, it seems very overwhelming. I don't even know where I should see and what's going on, and I lost my patience right there. But when I do the animation here, is since they show 3 bars at one time, so I actually can follow each one and see, oh, okay, so this is decreasing and increasing again, and then increasing and then decreasing again. So actually I can focus on what is the graph trying to tell me. So I think this is a very interesting and a very important, because when we really do the discussion from the Blackboard, we can find examples. We'll say, oh, this is nice, but we never know why this is nice. Only when we're doing the project on our own, and we will experience it, and we'll say, oh, this is really cool, really nice. And then, as you can see right here, the total traffic for October 2015 is the highest. It's way higher than 16 and 17. I think there are like probably 2 reasons behind it. Now, the first reason is definitely the collection of the data. We definitely have to question how they collect those data, where they collect those data. Also, when I see the data, some of them has NA, which means there's no information for that time of a period. So that will make this is a little bit inaccurate, as I think. So the way that I deal with this NA, I just simply replace with the mean, the average. But actually, it's probably not true, because we know that during the nighttime, like really, really late night, it definitely is slower. The traffic is slower than the morning time. So there's one reason for it. And another reason for that is maybe there is something that for 2015, maybe people still didn't realize how important the environment gonna be, or they didn't realize how expensive to go to the city with their cars. Now, start from 2016 and 17, people start to realize it. So people probably will go to the city by carpool, by train, by public transportations. So they figure out a different way to get into the city. Maybe that's another reason. The reason why 16 and 17 is slightly lower. But anyway, the reason why I really want to point this out, the animation, it took me a while actually to come up with this idea. But I think it's really, really cool, because it's really show you like step by step where the graph goes and the trend, and I think it's a very, very good idea. The next one, which is the last one, since the congestion pricing plan suggests that the car, regular car will charge for $11, and the truck will be charged for $25. So I was like, oh, since I have the different type of cars for different hours and like number of cars, so maybe I can find an estimation for the price and for the total. So this is what I did. So I still did October for 2015 and 2017, and I reorganized all of the data here. And then I find there are 7 types of cars in the data set. So there are auto, taxi, commercial, medium truck, heavy truck, school bus, and other bus. So from those 7 types here, I want to see like which part is the majority of the cars that drive in the city. So that this is the chart I got right here. I think it's pretty interesting. It's pretty cool. This package is called a waffle. I use the waffle for that because I feel like we actually really don't have to know like what's the exact percentage here. We just need to know like a general idea. Like, so that's why right here I have this 5 by 20 graph, the squares. So that means total is count as 100%. Now, as I did the calculation, we find that auto right here is around, you can count how many squares we have, so you can have the idea, is 76%. And taxi is a little bit, taxi is the second highest, but it's very much lower by 11%. And then everything else, as you can see, is smaller and smaller. I think that's pretty interesting and pretty cool to see that, because we really just need to know the trend. We don't have to know like exactly what number is. Now, as you can see here, from 2015, 2016, and then 2017. So the auto, which is the car, the regular cars, is always the majority of this entire, dominate this entire city. As you can see that. So now in this case right here, after we see the trending here, I come up with this idea to find their estimation fee charge. This is the table for that. And then when I think about how do I show this, is because there are 7 categories, there are a lot. So you're definitely gonna need a different color to show the stack histogram. So when I do the stack histogram there, because there are so many colors and there are so many close colors, and so they're kind of like squeezed in with one place and doesn't look really too nice. So, and also because auto has a majority of them, everything else, as you can see, this animation here is very, very small. So now in this case, I think the animation will be the greatest way to show it, to show the difference right there. So the number in the graph right here represented for my estimation fee collected. So in this case, after I calculate everything here, I got around $0.2 billion for a whole year. But what they suggest is they can collect for $1 billion to use for fixing public transportations, facilities. I mean, right here, I think that there are 2 reasons behind it. Now, the first reason is because again, it's a data collection. So how accurate the data collection is going to be. And then as I can see from the data set, there are a lot of NA information there. So I think that's probably the inaccuracy they have. That's the first reason. So maybe it really doesn't, well, actually there are 3 reasons. So that means the inaccurate information may lead to the $0.2 billion, which is way less than what they claim. And the second reason right here is the reason why they claim as $1 billion, because they want to, I think they kind of like want to encourage people to agree with this plan. Because this plan is such a controversial plan, a lot of people complain about it because when they entering the Manhattan, they need to pay for the fees, they need to pay for Easy Pass, and then now they have to pay another fee. So people don't like, in general, don't like it. But when they talk about, oh, we can raise such a amount of money and we can put that into our public facilities, maybe a lot of people will like it. So that's why I think they probably exaggerate the entire amount of money. Maybe it's not $1 billion. Maybe it's close to what my estimation. And then the third reason right here is because, I kind of forgot. So the first reason is lack of information. Let me see. Oh, yes. And sorry. So the third reason right here is because the month I pick is October. So it could be higher amount of vehicles in the summer, or could be higher amount of vehicles in the winter time. So the October probably is not the busiest month to represent for the entire city. So maybe it's below the average, maybe it's above the average. So anyway, it probably cannot represent for the entire year. So maybe some months it has a higher amount of vehicles. So that's probably another reason. So October maybe is not a good month to represent. So that's my third reason. All right. So so this is this is pretty much is my project. I mean, in conclusion, I mean, after I did this project, I kind of changed my mind. So I said that I want to be more objective before this plan, before I doing this project. But the thing here is I don't really like to be in charge for sure for entering my own city. But when I did this project, and I start to realize now, first of all, everybody complain about the traffic in New York City, but really nobody. Well, I mean, really not a lot of people willing to change the way they commute. So if they like to stay in the car, they still have to take that with them. Like they still have to drive into the city. So I mean, maybe this plan right here can make a lot of people think. Like for me personally, I would think, oh, you know what? This is probably good for the environment. It's good for everybody, for the generations. Also because the money they raise, they can fix a lot of public stuff as they promised. So I think it probably is a good thing right here. Financially, yes, it is a big burden for people who have to commute to the city. But from a lot of other reasons, I think there are more advantages than disadvantages. So I think I will say yes for this pen. So this is my whole final project. So that really for this entire semester right here, what I learned is a lot of cool techniques for the data visualizations. And also because before when I have this like this class, I always think that oh, so if I can show a lot of colors, that will attract people's attention. Or if I make this chart become really fancy, and people will like, whoa, this is so cool. But actually, if we look into those data visualizations, it's not just about cool graphs, cool animations. I think it's more about the graph. Can the graph tell the story? Can the graph attract people's attention? I think that's what I learned from this class, and I really enjoy this class. It makes me think a lot of different aspects about the graph, about visualizations. So I think it is pretty cool. So thank you.